Let me share my screen first. I'm gonna demonstrate a couple of C program, C++ program actually. So I'm going to show star.c++ here, but I want to just only show star.c++ till -4, the last 4 programs. Actually, let's just do not till -4. Yeah, here actually I have to do a list min xltr. This is the program that I want to demonstrate these two. Clear the screen and last two. So this is the two program in this case I want to show. If I just look at the content of each one of them in vim, vi demo, one of them is called the C-String demo.c++, which is the C-String library, which is the older version for C programming language, C style of library, C-String or string.h header files that we could just create an array and then or array of some elements here that is predefined, and then we copy using a string copy and then a string concatenation to add to the same string that fruit here. So fruit, the size is 50, and then we're concatenating these pears, grape, banana on the original string that we copied, which was apple. And then as we do it, for the cat, which was 3 characters into the array of cat, 3 characters, null pointer is always on the C string. There's always a null pointer is assumed if you don't type it in. On these ones it is assumed, but in this one, since it's a 1 character at a time, we put the null pointer, which is /0. And 3 characters in this case is the actual length of this character, which was the string would be cat when we print it and the size would be 3 characters. For these ones, for each one of these ones, since is each element would be fruits of I, would be I being 0 is apple, pear would be 1, and then grape would be 2, and banana would be 3. So in this case, the string length is 4, and then banana would be the 3rd element, the 4th element, but the index would be 3. And then apple would be the 1st element, would be index would be 0. So we will run that one and then get the string length output of this string cat, and as well as the string length of fruit, as well as we're going to write the size of the entire, the length of the entire fruits. So let's just compile it, and then we say g++ -o C string demo. That's to just say the compile it as well as link it. So if I just put the -c option, that's compilation only. But if I give -o option, in addition to compiling it, it also does the preprocessor linking and everything with assembly code, intermediate files, everything, and then it generate a executable binary file called, the output would be C string demo as executable output file. And then the source code that in this case is using is demo.c++, C string demo.c++. So there's no error, therefore $$ question mark is 0, meaning successfully compiled. Which means that now I have a couple of files, C string demo.c++, and then the executable file. In this case, is showing in green color. That means it's Linux knows that this is an executable file. And also the type of that file is executable. And then the permission for the owner, which is in this case wlutfi, it has read, write, execute. For the group, it has read, write, execute. And for others, meaning everybody else, but that are not WLUTFI in the group WLUTFI, that could be development or other groups, they are all having read and execute, not write permission. So the file cstring in Linux or Unix, when you type in file followed by a file name or a directory or a list of files, in this case, a star, meaning that show me this and this, the type of the file they are. The first one, which is the binary, it shows that executable link format here, 64-bit, and then it's a shared object there. And then the second one is the source code, ASCII to text. You can see C++ source code. If I do LDD on this first one, cstring demo, you can see the shared objects that are at the preprocessor that were included in this modules, whether we're statically linked or shared object linked. These are the so means shared object link. So they're all attached to it. And then when I run it now, I should get the output based on my code that cstring demonstration does. So in this case, cat is 3 characters. The string was cat, and then the length of it is 3. Apple, pear, grape, and banana was concatenated, and the length of the string now is 23 characters. All the characters are showing here. Similarly, I want to do a demo string .c++. This one, so demo string .c++. This is much better because it has less limitation than C string. The string module or string library of C++ has a lot of functionalities. It is basically pre-written everything that was on a string, C string, in addition to adding more functionality and features to it. So some of the functionality is that when you define it, for example, in the C string, you had to now terminate it every characters of a string. At the end of it, it was just, you had to write a null pointer there. Some of them at the time when you don't type it, it is assumed. Here it is assumed everything is at a null pointer there, terminated, and depending on the size of it, so this one is the size is 3, and then this one is the size of this array depends on how many elements on this one. So this one would be, apple would be fruit sub 0, and pear would be fruit sub 1, fruit sub 2, and fruit sub 3. So there's 4 elements in it. And then when you go through a for statement, the cat size is a function that is defined in this string. It will actually give you the size of the string, whatever is the size of it. So if this is apple, this would be 5, and pear would be 4, and so on. The size of is different. The size of is showing you the type of storage, how much storage this string takes. So a storage, normally a character takes 1 byte, and a string takes 32 bytes. So for each string that you define, you take 32. And if you are storing 4 of them, then 4 times 32 is 128 bytes of storage requires for all of them together. So if I just run this one, compile it, and just say G++ -O demo string.c++. Let me actually clear my screen and then do here demo string.c++ is the code. So I'm going to just say G++ -O demo string, and then from just generate that demo string as executable from demo string.c++. Since the output again is $? is 0, meaning that the compilation succeeded. So now I can say do demo string and then I get the output. Notice that this time the output is showing cat is the string is cat, and then the length of the cat is 3, and then the storage size for the cat is 32. because a string takes 32 bytes. Whether it is 1 character, 2 character, 10 characters, still takes 32 bytes of storage. And then a character takes 1 byte. Integer takes 4 bytes. A long takes 8 bytes, and so on. So in this case, the string storage for each string, it takes 32. As you can see, the cat took 32, the apple took 32, pear took 32, grape 32. And then if I just want to count for all the fruits, I can get into a basic calculator, say 32 times 4 is 128, including the 32 times 5, including the cat, is 160 bytes. Altogether, it took a space. So that's the demonstration of that as an example. I hope you learned something from it, and if you did, you enjoyed it, that's great. And if you didn't, that's also okay. Have a nice one. Let me